Natural logarithms. Definition of natural logarithms. A logarithm with a special base called e is a natural logarithm where e is an irrational number. Rounded to the nearest 10,000th, e equals 2.7183. Definition: natural logarithm. A natural logarithm is a logarithm with base e. We write ln parentheses a to represent log base e of a. Exponential natural logarithmic forms property. For a greater than 0, the equations ln parentheses a equals c and e to the c power equals a are equivalent. The natural log of a is the exponent on the base e that gives a. For this example, use a calculator to find the natural log of 40. On our calculator, we can find our natural log right here. If you look above it, you have your e to the x power. To find the natural log of 40, press your ln button and then type 40. We don't have to close the parentheses since we're not doing anything else, but we can. Press enter and we get 3.688879454. Using 4 decimal places, the natural log of 40 equals 3.6889. In this example, find the natural logarithm. Use our calculator to verify the result. For part A, we have the natural log of e to the 4th power. Since the natural log is the same as log base e, we know from our earlier sections that if your base and your answer are the same, they cancel out, leaving you with just the power. So this result should be 4. Going to our calculator, we type our natural log, then in the parentheses we want to type e to the 4th power. So second natural log, it already gives us the exponent when we use e, 4. Then we close parentheses, enter, and I do get 4. So the natural log of e to the 4th power equals 4. For part B, we have 1/2 natural log of e to the 6th power. Again, the natural log and e cancel each other out, leaving me with just 6. So that means we have 1/2 times 6, which gives us 3. Calculating, we have parentheses 1 divided by 2 times the natural log, second ln to get e to the power of 6, and we get 3. So 1/2 times the natural log of e to the 6 equals 3. In this example, solve the equation. Round any solutions to the 4th decimal place. 2 times the natural log of 5x minus 3 equals 1. We'll work this problem similar to working our problems with the log when we have to solve for a variable. It's helpful to remember that the natural log of a equals c and e to the c power equals a. Our first step is to isolate the natural log of 5x. I can do that by adding 3 to both sides, leaving me with 2 times the natural log of 5x equal to 4. Then dividing both sides by 2, the natural log of 5x equals 2. Now we're ready to rewrite it in the exponential form. So I have e to the 2nd power equals 5x. Dividing both sides by 5, I have e squared divided by 5 equals x. And now I'm ready to calculate. So to get my e, second ln, 2 divided by 5, enter, and I get 1.47781122. Rounding out to 4 decimal places, x equals 1.4778. In this example, we want to solve the equation, round any solutions to the 4th decimal place. 7 times e to the power of 2p plus 10 equals 100. For this problem, we need to rewrite it as a natural log. Our first step is to isolate my e to the c. I have it equal to a so that we can rewrite it as the natural log of a equals c. Dividing both sides by 7, I have e to the power of 2p plus 10 equals 100 divided by 7. Now I can rewrite it as a natural log. My natural log of a, which in this case is 100 divided by 7, equals c, which is 2p plus 10. Calculating, I have the natural log of 100 divided by 7. That gives us 2.659260037. It's best to have as exact an answer as possible. For best results, you want to wait until you're done calculating to round. With the TI calculator, that can actually help us because in all of our calculations, we can continue to use this answer. For my work, I'm going to round it to 4 decimal places. 2.6593 equals 2p plus 10. Now I want to subtract 10 from both sides. Calculating, I can just type minus 10. It will immediately subtract it from the answer. Enter, and I have negative 7.340739963. I'm still going to round to the 4th decimal place, which gives me negative 7.3407 equal to 2p. I want to divide both sides by 2. Going back to my calculator, I can just press my division sign, 2, enter, and I get negative 3.6703699982. Rounding this to the 4th decimal place, I have negative 3.6704 equal to p. So for my solution, p equals negative 3.6704. Natural logarithms. Our natural logarithm is a logarithm with a special base called e, where e is an irrational number 2.718218228. We can write the natural logarithm as ln of a, where ln represents log base e. For all logarithms, assume that x is greater than 0, y is greater than 0, b is greater than 0, and b does not equal 1. The following properties will apply. For the property of a logarithm, log base b of 1 equals 0. For the natural logarithm, the natural log of 1 equals 0. The natural logarithm of 1 is 0. For the property of logarithm, log base b of b equals 1. For natural logarithm, ln parentheses e equals 1 because the natural logarithm of e is 1. For a logarithm, log base b of b to the x is equal to x for any real number x. For your natural logarithm, ln parentheses e to the x is equal to x for a real number x, composing y equals ln x with y equals e to the x. For logarithms, b to the exponent, log base b of x is going to equal x. For a natural logarithm, e with an exponent of the natural log of x equals x, composing y equals e to the x with y equals the natural log of x. For a logarithm, log base b of x to the p equals p times log base b of x. For a natural logarithm, the natural log of x to the p equals p times the natural log of x, which is your power property. For a logarithm, log base b of x plus log base b of y equals log base b of x times y. For a natural logarithm, the natural log of x plus the natural log of y equals the natural log of x times y, which is your product property. For a logarithm, log base b of x minus log base b of y is equal to log base b of x divided by y. For a natural logarithm, The natural log of x minus the natural log of y equals the natural log of x divided by y, which is your quotient property.